Welcome, everyone, and thank you for joining us for the Women's Interprofessional American Network of the American Diabetes Association Spotlight on Women in Science interview. And today we will be hosting Dr. Barbara Kahn. Before we begin, I'd like to share a little bit about the WIN ADA and our goal and mission. The Women's Interprofessional Network of the American Diabetes Association is our members-only network for female clinicians, scientists, educators, and other health professionals in diabetes. We are a multidisciplinary dynamic group, and our goals are simple yet profound. We aim to strengthen the voice and presence of women in diabetes research and clinical practice, and recognize the significant contributions of women to the diabetes field. And that is what we will be sharing and spotlighting today with Dr. Barbara Kahn. My name is Dr. Jennifer Lee. I am a basic scientist and scientist 2 at the John Mayer USDA Human Nutrition Research Center on Aging at Tufts University, and assistant professor in medicine at Tufts University School of Medicine. I was actually a mentee of Dr. Barbara Kahn, so it is a beautiful full circle today to be able to host her on the podcast. And I would like to, I'm also co-chair of the WIN ADA, and I am so happy to be here with my co-host, Dr. Tanaz Moin. Tanaz?
Thanks so much, Jennifer. And it's really a pleasure to be here. I am an endocrinologist and a physician scientist. I'm an associate professor of medicine here at UCLA, and I have a dual appointment at VA Greater Los Angeles, and have been a WIN advisory group member for a number of years now. So really a pleasure to be here and so excited to get this podcast going.
It's my honor to introduce Dr. Barbara Kahn. She is the George Richards Minot Professor of Medicine at Harvard Medical School, Vice Chair for Research Strategy in the Department of Medicine at Beth Israel Deaconess Medical Center, and an institute member of the Broad Institute of MIT and Harvard. She is internationally recognized in the area of obesity and type 2 diabetes, and her lab over many decades has investigated the molecular mechanisms underlying these conditions, including the regulation of insulin sensitivity, adipocyte biology, and intertissue communication. Dr. Kahn has received her BA and MD degrees from Stanford University and an MS in health sciences from the University of California at Berkeley. After completing internal medicine training and a general medicine fellowship at the UC Davis Medical Center, she began her career in molecular research at the NIH, where she also completed a clinical endocrine fellowship. She has served as chief of the diabetes unit and chief of the Division of Endocrinology, Diabetes, and Metabolism at Beth Israel Deaconess Medical Center. She's also served on the board of directors of the American Diabetes Association and on the advisory council for the National Institutes of Diabetes, Digestive, and Kidney Diseases. She is widely lauded for her pioneering research. She's an elected member of the National Academy of Medicine, the National Academy of Sciences, and the American Academy of Arts and Sciences. And she is also a fellow of the American Association for the Advancement of Science. Dr. Kahn has received numerous awards, including the American Diabetes Association's Outstanding Scientific Achievement Award and the Banting Medal, which is the highest award for scientific achievement in the diabetes field. She also received the Jacobus Prize from the Novo Nordisk Foundation and the Karolinska Institute, the Charles H. Best Award from the University of Toronto, the Gerald D. Auerbach Award from the Endocrine Society, and the Excellence in Science Award from the Federal Federation of American Societies for Experimental Biology. And she will also be receiving the Endocrine Society's George Greep Award this summer. Welcome, Dr. Barbara Kahn.
Thank you so much for being here with us, Barbara. You have had such an amazing and inspiring career. And I wanted to ask you for us to just start off, and if you could share with us a little bit about your earlier parts of the career and sort of your journey to becoming a physician scientist.
Well, first of all, thank you all for inviting me to do this interview. And I hope that anything about my career can be helpful to other women developing careers in academic medicine and research. So I was actually interested in science and math even in junior high school. And one year, the math teacher asked me to write the exam for the other students. And the students found out, and the boys in particular really made fun of me. And they drew a picture of me like a ticker tape machine, with the tongue being the ticker tape. And I knew I had to get out of there. So I asked around and so on, and I found out about an all-girls school in Kansas City. And that's where I was for my 4 high school years. There were only 27 people in my class. And they actually had a special math class for 3 of us, where they got a teacher to come in from a nearby junior college. So, I really got to experience math and science. But I have to say, when I arrived at Stanford as a freshman, I was not all prepared for the science courses, although I did okay in math. But at Stanford, I thought I would major in astronomy or anthropology. But there was a brand new program there called Human Biology, and it was really terrific. It was run by Donald Kennedy, who was later head of Health and Human Services and then president of Stanford. He taught us about butterfly migration, but Jane Goodall came and taught anthropology and primate behavior. And William Dement discussed narcolepsy long before the genetic tools existed to find the genes for that disease in his colony of narcoleptic dogs. So I became really fascinated with biology and behavior. And at the same time, in the dorms, eating disorders were rampant. And I really felt there was a lack of understanding about the physiological and psychological factors that drove these disorders. And at the same time, I always held this sort of perplexing situation in my mind. When I was growing up, my grandmother had these incapacitating headaches. They were probably migraines, but the diagnosis wasn't made in the 1950s. And no one knew why she got these or what could be done about it. So I was sure that it was possible to know more about human disease and human behavior. And so I started to get interested in science and how that might come about. And there was actually a movement then in the San Francisco Bay Area, but I'm sure it was also in Boston and New York and other major cities. And it was a women's movement called Our Bodies, Ourselves. And it was all about women taking control over their bodies. So I was very intrigued, and I actually took some time out and I went to work with the Berkeley Women's Health Collective. And I worked in the Berkeley Free Clinic with many different health professionals, all of whom had very important jobs. And it was then that I realized I wanted to become a physician because I needed to know that level of understanding about human physiology. So I decided to go to medical school really to find out how the human body works and to change the way medicine was practiced so patients and families could be more involved. I did my first 2 years of med school at UC Berkeley, which was an experimental program at the time. We took basic science courses in the Berkeley departments. We had clinical correlations with physicians in Oakland and Berkeley, and it was a terrific program. But it was only 2 years, so I transferred back to Stanford for my last 2 years of medical school. And then I did my internship and residency at UC Davis in Sacramento. Now, why did I go into research? Well, at the end of my internship and residency, I really didn't want to just follow along in the mold. I felt like I really wanted to figure out how I could make a contribution in the field of medicine, and I hadn't really come around to research yet. But at the time, general medicine fellowships became available, and they were brand new, and there was no job description. So that fit me very well. They just needed for people to do some research. So my first research project was actually a clinical study I designed to compare urine and blood glucose monitoring for people with diabetes. So around 1980, blood glucose monitoring was not being used widely at all. And there were a few studies out of the UK implying that it was great, but they weren't controlled and there were small numbers of people. So I designed this crossover study of blood and urine monitoring for people in our county hospital population. And I convinced the company to donate the strips. And I got nurses and nutritionists and so on to participate. And what we found was that anybody who stayed in our study improved on either the urine or the blood monitoring. So I was very intrigued, and these results were different from what was being reported from the UK. So I contacted the investigators in the UK, and they invited me to come visit their centers. And while I was there, they took me on a tour around the laboratories. And then I realized that diabetes care did not have to be so depressing, and that research was the key to new treatments and prevention strategies and better quality of life for people with diabetes. So I decided to do research, even basic science research. Sorry, I feel like I'm talking a long time.
No, that's so amazing. I mean, it's such an interesting story and how all of these sort of pieces, right, build on one another. That's wonderful, Barbara. And as you know, we have so many hundreds, probably at this point, fellows and junior faculty, across the country who are also really just excited to pursue research and become physician scientists and make their path towards independence. What do you think they should consider and prioritize to be successful?
Well, I think that when you're starting to embark on the idea of an independent career, it's important to choose a research area that will be impactful and that will distinguish you. It's important to be focused, even though there's a temptation to do a lot of projects because maybe one or two won't work out. But you want to become known for certain expertise. And I think it's important to publish. So don't try for your first papers to be in Cell Science and Nature, because that may take longer. And to get grants and so on, you need to be publishing. Another thing I would say is to hire wisely. It's really important who you hire to be in your lab. And there's many considerations that I could mention, but be very deliberate about your hiring and figure out what you're looking for to build your team in your lab.
Thank you for these insights. And I think the broad background that you've given really makes this such a wonderful, personalized interview. This is definitely the space for it. We are so glad that you can join us for the WIN ADA podcast. So I'm going to do a bit of a shift to science now. You are a pioneer in adipocyte biology and glucose metabolism. How did you come to define your research program, and what continues to inspire you after all of these years?
Well, I actually chose to work in Sam Cushman's lab at the NIH because I wanted to know how insulin works. And they were studying very new findings by Larry Wartzala in the lab that insulin elicits the translocation of glucose transporters from intracellular reservoirs to the plasma membrane, and that's really important for regulating glucose, and especially after a meal when insulin levels are rising. So I was intrigued with that whole mechanism. And that led us to an observation years later that the GLUT4 glucose transporter was really tightly associated with insulin sensitivity, downregulation of GLUT4 in adipocytes in people was associated with insulin resistance. So we wanted to know, could glucose uptake and GLUT4 in adipocytes really contribute to systemic insulin sensitivity? And so, we overexpressed and knocked out GLUT4 specifically from adipocytes, and that did have a profound effect on systemic insulin sensitivity and on insulin action in muscle and liver. So I think it's been really stimulating how the field of adipocyte biology continues to progress. New technologies, single-cell RNA-seq, have been incredibly revealing about adipocyte biology. I think that continues to be a really exciting field.
Thank you so much. I have another question. Can you share one or two examples of memorable scientific eureka moments in your research and or clinical career that gave you the most joy or is the most memorable?
Well, I think what gives me the most joy is working with young investigators and seeing their careers develop and seeing their scientific successes. In terms of the lab per se, when Peter Shepard, my first fellow, who's now a very successful scientist in Auckland, New Zealand, where he's from, when he first overexpressed GLUT4 in adipocytes and did the initial glucose tolerance test with Effie Tozo and Luigi Nudi, who were fellows at the time, and that we saw that overexpressing GLUT4 in fat actually markedly improved glucose tolerance. That was an incredibly exciting moment. I mean, very little had been done with the adipose-specific overexpression or knockout, and the fact that adipocytes were so important for insulin action was really, for insulin action in vivo, was really rewarding. I think a second eureka moment was when we collaborated with Alan Sagatilian and we did untargeted lipidomics to look at the lipids in these adipocytes overexpressing GLUT4. And through that, we found a class of lipids that had never been described before. And then Jen was part of these studies when we showed that those lipids actually affected glucose homeostasis. That was another extremely joyful and exciting experience.
That was a really great time in the lab. I have fond memories of those times. I have another question. So the delay from a published finding to the time when that finding is finally recognized or discovered by the field can be significant and requires perseverance. Can you share any strategies that you have employed to navigate this challenge?
So in terms of how long it takes to actually get a paper published.
Yes.
again, I think it's important to um, figure out, where you want to publish, because the higher you go with the journal, the longer it will take probably to publish. But I think it's good to present abstracts at ABA and Endocrine, Keystone, FASTSEB, Gordon conferences. Also, be very active in those meetings, ask questions, introduce yourself, and sort of become known. Seek out contacts with more senior people who are working in the area. If possible, find opportunities to chair sessions and so on, so you can become known. Sometimes people worry about presenting before you're ready to submit the paper. And yes, it is possible to get scooped, but I think there's also the opportunity for preprint publications now.
Thank you for those insights. That's very helpful, especially for junior faculty. You are the only woman in the history of the ADA to receive both the Banting Medal and the Outstanding Scientific Achievement Award. You were the second woman to receive the OSAA award, and with the first being Rosalind Yalow, who won a Nobel for developing the insulin RIA. This is a significant scientific career achievement. Regarding the Banting Award, first, how did the nomination come about?
Well, honestly, a longtime colleague actually emailed me, and he said he wanted to nominate me for the Banting. And I was surprised because I knew he was also being nominated. So I said that to him, and he said, "That's okay. You can get it first, and then I'll get it after that." And in the end, two different colleagues separately nominated me for the Banting.
Wonderful. And the second sub question to that is, was this always a goal or on your bucket list in your career?
It wasn't always a goal, but mid-career, or 15 years after I received the Outstanding Scientific Achievement Award, it was so noticeable that no women were receiving the Banting Medal. I think there was a gap of several decades, really, from when Ora Rosen won it, many years ago, to when Barbara Corky won it. And so I just thought that wasn't right, that women needed to be recognized at that level in science, in the diabetes field. So then it became sort of a goal.
And how do you define big impact science? How do you advise early stage and junior scientists who are currently establishing, how would you advise junior faculty who are establishing their research careers?
There are probably many different definitions. I think sometimes it means data that cause a paradigm shift, and that shift is then built upon to drive a field in a new direction. Or it can be development of a technique or technology that enables much more powerful data generation. In biomedicine, I think big impact science usually leads to a better understanding of biologic processes, physiology, or disease pathogenesis, or therapeutics. I think it's very important when you are choosing research directions to think about the impact. And, even if you're not writing a grant, think about what you would say in the specific aims for why it's really important to answer the question you want to answer.
And my last question for this section is, what do you enjoy most about science?
Well, I enjoy the process of scientific discovery. It's just so exciting to discover something new. And I especially enjoy that when working with young scientists and seeing them develop and seeing them, pursue their own original ideas. That's really very rewarding. I also get, some enjoyment out of figuring out if a new discovery is relevant to human physiology and disease, and whether it could make a difference in the diagnosis, prevention, or treatment of disease. And then the last thing I'll say is I really enjoy collaborating with other people, with other expertise, and the teamwork that, is involved.
Thank you, Barbara. You've touched on, yeah, there are so many things to love about science. And I think actually some of the themes are irrespective of your area. I mean, you can be a basic scientist, clinical, translational, or a health service. This is really wonderful. And I was just wondering, as you talked about the junior and sort of rising physician scientists, maybe to share with us a little bit about some of the ups and downs in your career and how you weathered times of uncertainty and sort of wisdom that you can share with us about that.
Yeah. I have experienced some disappointment when some very talented trainees who had done well and had had important papers published in high visibility journals leave the lab to go into industry. And I've always wondered if I could have done something different to keep them in academia. Now, I hope I'm not offending anybody who did that, because more and more now, I think the industry positions can be very rewarding and can lead to important advances for human health. But we need strong scientists in academia, and in particular, I think physician scientists are dying out. We really don't have a good pipeline of those. Another moment that was a shock for us was when a pharmaceutical company published a paper negating some of our findings. And we were very surprised by it. The journal told us about 12 hours before that they were publishing this paper. And after we got over the shock, we decided to publish a response which explained the numerous flaws in the experiments in this other paper. And I also contacted an investigator in Europe who was working in our area and asked him what he thought of the paper. He also thought it had major flaws, so I suggested he also write a letter. So the flawed paper and both of our letters, including ours, which contained new data, were published in the same journal. And I think we got some resolution, but, that can happen, that some of your major findings can be really challenged by other groups.
Yeah, no, that's really important. And I guess as a follow-up to dealing with, setbacks or sort of unexpected challenges or even rejection, tell us a little bit about maybe specific tools and strategies you use to deal with these types of situations.
So when you say rejection, I think about rejection of manuscripts,
Yep.
rejection of grants,
Grants.
or rejection of your scientific ideas or conclusions. So about rejection of manuscripts, many outstanding papers are initially rejected. The paper by Burson and Yallo reporting the first development of radioimmunoassay, which, their assay was for insulin, and they later won the Nobel Prize for this. That paper was rejected by the Journal of Clinical Investigation. And even the first revision was rejected. And then finally they got it in. Ron Kahn and Jesse Roth wrote a paper about that whole process many years ago. But excellent papers, those for which the Nobel Prize is eventually awarded, can be initially rejected. So I think one has to make the decision of, do you fight with that journal or do you go to another journal? And I think it has to do with timing, how much you need that paper at that time, and so on. Sometimes it pays off to try to go back with, revisions and rebuttals, but that can take a year and then it's still not accepted. So sometimes it's worth it if the finding is really phenomenal and you have the time to wait. I think about the rejection of grants, the study sections are made up of a diversity in terms of a number of factors, including geographic diversity. So I know some people are more experienced on the study section than others. And I think it's very important to read the comments, see if they're comments that make sense and you can address, or if you think it's really unfairly reviewed, see if you can have it reviewed in another study section. But addressing the comments can be helpful, although study sections turn over. And so the next time it's reviewed, there may be new comments.
Those are great suggestions. And I hear sort of a theme of perseverance and tenacity, right? So believing in something and sort of really just continuing to plow forward, even if there are setbacks and challenges. That's definitely a common theme. So tell us, Barbara, about mentorship. And I'm curious if there were specific mentors who influenced your career in particular.
Right. Yes. So when I was a medical student at Stanford, I thought I was going to go into family practice. I was very interested in helping people at the grassroots and, helping people with chronic illness cope with those illnesses and have productive lives. And when I was on the endocrine service, Dan Fetterman, who was chief of medicine, was my attending. And Dan Fetterman was a phenomenally effective and inspiring teacher. He was the kind of person where any question you asked was really an astute, brilliant question, And so as chief of medicine, he met with the, graduating classes about their futures. And he strongly encouraged me to go into internal medicine and not family practice, because he thought I wanted to understand things in more depth. And I will always appreciate that. The second mentor was Sam Cushman, who was a cell biologist at the NIH. And he took me into his cell biology lab, even though I had never used a pipette and I had no basic science experience. And he provided an environment where I could learn basic science, even at that sort of late stage of my training. And he also taught me to be rigorous and to be patient, even if it took a long time to get definitive results. And then I want to mention a third mentor who was Jeff Flyer. So Jeff recruited me to Beth Israel Hospital and Harvard Medical School when he was chief of the diabetes unit at Beth Israel. And Jeff had a great love for science, and he is a very original thinker. So not only did Jeff secure initial funding for me on a physician scientist grant, but he also provided critical collaborations, such as with Harvey Lodish's lab, who had cloned the first glucose transporters. And I'll always be grateful to Jeff for encouraging me to think outside the box.
That's wonderful. So, we know what an important role mentors play. And I think another theme that is critical for success is building solid supportive teams to support the science that you're pursuing. And we're wondering what strategies you've used to build the incredibly successful teams you've been fortunate to be part of and to lead, Barbara.
Yeah, building teams, you don't really have a guarantee of whether personalities will mesh, and whether people will feel that they want to support others. But I think, again, very careful and deliberate hiring is important. Keeping communication open all the time. When the lab was larger, I would meet with small groups to foster collaboration, have meetings with those groups with outside collaborators, invite outside collaborators to come to our lab meeting. And I encourage a lot of discussion in lab meeting. And I do think that social events for the lab are also very helpful.
Yeah, and I'm really want to echo that sentiment. I feel like now more than ever, right, with our Zooms and virtual, really trying to make sure that there's opportunities for our teams to get together and interact in social ways is so important. So tell me, Barbara, about when there's a weakness or there's a skill set that you're looking to improve upon, whether that's technical or career-based. Do you have specific strategies you've relied on in the past?
So science advances and it will continue to advance. And when you are later in your career, you will want to use techniques that you've never had experience with. So I think collaborating with people who are experts is helpful. Hiring people who have the expertise is also helpful. And, going to courses and encouraging your trainees to attend courses. Nobody should apologize for not understanding the newest techniques. Science will always continue to progress and have technological advances that enable deeper and broader discovery.
That's fantastic. This is a tough question, but I was wondering if there was one thing you wish you knew earlier in your career or advice you could now share with your younger self, what that might be.
That is a tough question. And the thing that comes to mind is when I was a junior faculty member, I had colleagues at other institutions. And in particular, a couple of my colleagues at the University of Michigan started a Women in Science group. And they were all like assistant professors. And they met and they helped each other with their grant applications and their, letters if they, needed to apply for something, and also sort of prepped each other for interviews for leadership positions. And they encouraged me to start a group here at Harvard. And honestly, I didn't know enough women in science to be able to do that here. And I didn't feel the same supportive attitude that they seem to have among the few women that I did know. But I think it's critical to have support from peers. And I think it's phenomenal what insights you can get if peers will read your specific aims or read your manuscripts. So I really encourage people to have peer support groups, to be able to move even faster, especially if you're interested in leadership positions.
Yeah, that's such wonderful advice. And those groups can be done again in person, virtual, and with women and colleagues across all the disciplines. Barbara, what do you think about that idea?
Well, that's true. And, you know, it doesn't have to be women. I mean,
Yeah.
I just told you about my 3 male mentors.
Right.
So, yeah, I mean, other assistant professors, or if you can get people even a little ahead,
Yeah.
I think, you know, one really does have to advocate for oneself in this field. And it I mean, gone are the days where there's one mentor who really
Right.
has the time to be very focused on your career for many years. One needs sort of a network, a collage of mentors that you can call on at different times for different aspects of things.
Well, I think I am very lucky that I had you as my mentor, Barbara, and you were able to foster both the science, the rigor of science, and to give insight into how it is to be a female in academic research. So I think this podcast is such a nice way to be a more global mentor with the strategies and advice that you've given here, that others would otherwise we wouldn't otherwise be able to hear unless we interacted with you more. So it's so nice to have you on this platform. So speaking more broadly on the topic of women in science, as an advocate for women in academic research, what are the critical things that you think we can help to that we can do to help women in our field or science community in broadly to succeed?
So I think, you know, I've always wanted to put women in visible positions. So if I'm chairing a meeting, a Keystone meeting or a FASTA meeting, make sure women get a chance to present, or if they're not that far along, then to chair a session. So I think trying to put women in more visible positions is really important. I do think that reviewing each other's grants and so on can be very helpful, and you can help even more junior people to move up in their careers. And then, you know, we started at Beth Israel this Advancement of Women Committee. I think it started before you left, Jen. And that was actually in response to a cultural survey that was done. And this survey was done at many, many medical centers where the Department of Medicine at Beth Israel scored below the national average in terms of being a you know, supportive place for women. And that covered many things, including salary and childcare and, you know, scheduling and on-call, as well as mentorship and leadership and opportunities to advance. Interestingly, the Department of OBGYN at our same institution scored above the average. So it's not about being, you know, at a Harvard institution. But anyway, the Advancement of Women Committee has been very effective, I think, in working on all of these fronts, from the social aspects, meaning the childcare and so on, to, you know, what the salaries are, to demanding that all new leadership positions are posted so that people can apply for them. So I think that one can do a lot in that sort of forum. And I will say that there have always been a couple men on the Advancement of Women Committee. So again, build a coalition of everyone who's supportive.
That's wonderful to hear. So with this next with what you just said, and these more systemic changes, have you observed any positive outcomes in the scientific or academic community in response to these efforts?
I have observed huge changes. Now, you younger people may not perceive that, but just as an example, when I became chief of the division of diabetes endocrinology and metabolism at Beth Israel, I was one of 27 division chiefs, and I was the only woman. And every month, I would sit in this in-person meeting with 26 men and me. Now, truthfully, that hasn't advanced so much. There's still only one woman, I think, or possibly two division chiefs in our department. But I think there's, much, it's still an ongoing process to reduce implicit bias. But I think if you point it out to somebody, they'll realize it much more now than 20 or 25 years ago. I also think, now if we want to recruit a new division chief or department chair, you have to meet certain metrics for diversity. Now, what the current, U.S. administration may do to this, it's hard to know, but the medical center and the Harvard Medical School has metrics that have to be met in terms of who you choose to interview and also what kind of questions are asked, and that's standardized for all applicants and so on. So I think there's also more opportunity to split like clinical positions if people don't want to work full time because they're raising young children. And I think there's much more advocacy around salaries and benefits, admin support for different faculty members. So I do perceive advances.
And I definitely feel them more broadly and recognize all of the limitations that the older generation of female scientists had to endure. So we are all generally so grateful that you have been spearheading and continue to advocate for us. So I have one last question in this Women in Science section. Are there any factors that continue to or newly limit women from equitably advancing their careers in the research community?
That's a difficult question too, but I'll just reiterate that it's very important for women to advocate for themselves, individually and as a group. And supporting each other is very important.
Yeah, absolutely, Barbara. And, I think we know now more than ever, how challenging it can be to be in science. Sometimes science is stagnating, and we know it's becoming increasingly competitive. And this is, of course, both for women and for men and for individuals in all areas of science. But I was wondering how you would advise young people who are looking for those great unanswered research questions, that it's worth continuing to pursue their efforts, and that, being a physician scientist is one of the most rewarding career paths.
Yes. It definitely takes perseverance, but it is very rewarding. And, at various times in your life, if you're trying to be a physician scientist, you may have to dial up or dial down the two sides of your career to be able to push forward, a certain aspect. You can't get overly clinically committed and still be successful in science unless you do it very collaboratively. But again, I think that publishing even smaller papers to establish yourself, and then prepare yourself for the competitive aspects. It is competitive. If you think you may be challenged when you present at the next Keystone meeting, prepare your response in advance. Talk to your colleagues about what you might say. And I do think, as I mentioned in the beginning, establishing a scientific niche so you're known for a certain expertise is really helpful.
Yeah, and that applies. I mentioned physician scientists, but I realize that at ADA and elsewhere, really important contributions from our PhD trained scientists as well. And I think the points you're hitting on really apply to all of us equally. So that's fantastic. And as we kind of get to the close of this session, I was wondering, Barbara, if you had a favorite quote or a mantra or motivating thought that's helped steer your career, and if you'd be willing to share that with us.
Well, there are a lot of important decisions you have to make in a career in science and in academic medicine. And I often think about something my mother used to say when I was trying to decide whether to take this or that leadership position. And she would say, well, after you've listed all the pros and cons of each choice, instead of continuing to struggle with, quote, making the right decision, focus on making the decision and then making it right. Mm. And that was really helpful to me to get me unstuck, to be able to move on with some decision that I made.
That's really beautiful. And I would say, listening to our mothers, I can channel my own, is always very wise, but that's really, that is very, very, I think, applicable to science, because there are so many decisions, right? And so you can, get paralyzed in that process. That's wonderful. And I think I've definitely written that down. I'm going to be adding it to my list of inspiring notes. So thank you, Barbara. This was really such a pleasure, and we're so fortunate that you were able to make time to spend with us today. And I want to thank Jennifer as my amazing co-host, and really everyone at WIN ADA for making this session possible. All of the efforts to continue to, as the title of this podcast is Spotlight on Women in Science. Barbara, you're really, I think, an amazing sort of person, a scientist, woman, and what an incredible inspiration you are for all of us. So thank you all for being here, and take care.
Thank you very much.
Thank you, Barbara.
Thanks everyone again for joining us today for what was our second Spotlight on Women in Science with Dr. Barbara Kahn. We hope you enjoyed the session today, and we'll keep an eye out for more of these podcasts, which will be coming your way. And please do go and learn more about WIN ADA and the number of activities and opportunities that are available for female clinicians, scientists, educators, and other health professionals who are interested in advancing diabetes. Thanks again.